This video demonstrates the simulation from the recent conference paper, Modeling and Simulation of Multi-UAV, Multi-Operator Surveillance Systems. These are the agents in the simulation and their real-life counterparts that they represent. They're the purple shapes representing quadcopters, the gray chess pawns that represent human operators, the cubes that can be red to represent threats like a tank, or green to represent innocent non-threats like a civilian car, and then the yellow fixed-wing UAVs that represent high-level surveillance UAVs. Here's the simulation in action. The first thing that happens is that all the fixed-wing UAVs start flying their routes, and they just fly at a constant speed at a high altitude. Every time they pass over a point of interest, they record its location and publish that to a database, and that looks like a gray square that appears around the points of interest. That means it's been discovered. After that, the operators send quadcopters to each point of interest to gather more detailed surveillance. So throughout the mission, the operators are doing two tasks. They're commanding quadcopters and they're also analyzing the intelligence as it comes back in. All of the different states and tasks that the operators perform are represented by different colors of the operators. For example, when they're red, that means they're idle. When they're pink, that means they're commanding the quadcopters. And when they're gray, that means they're analyzing intelligence and making a classification decision. The state of each point of interest is also represented by the color of the square surrounding it. When there is no square, that means that the point of interest just exists and it hasn't been discovered yet. Once it's been discovered by the fixed wings, it has a gray square. Once it's been photographed, it has a black square. And then once it's been classified as a threat, it has a red square. If it's been classified as a non-threat, it has a green square. You'll notice that sometimes the operators make the wrong decision. They may classify a non-threat as a threat or vice versa. These mistakes can sometimes be random, but they're also affected by human factors. The operators get fatigued over time, and if they're performing too many tasks at once, they can get mentally overloaded, and their decision accuracy goes down. And all of these human factors are represented numerically in the simulation. Here's the information about the paper again, including where you can find it online. If you'd like to contact the authors with any questions or requests for the code or other media from this project, all of the contact information can be found at the header of the paper.